So this question says a photocopy machine is initially loaded with 5,000 sheets of paper. All right, so let me just write down 5,000 to start. The machine starts a large job and copies at a constant rate. So that's important, constant rate. After 20 minutes, it has used 30% of the paper. Okay, so here's our rate. 30% per 20 minutes. But I don't want to have a percentage here, right? 30% of the 5,000 sheets of paper can be solved by finding 0.3 times 5,000, which is 1,500. So then my real rate is that this copy machine uses 1,500 sheets of paper per 20 minutes. Okay, and of course I can reduce that to a per minute basis, but I'm not going to do that yet because I'm not sure if I need to do that. So then the question says, which of the following equations models the number of sheets of paper P remaining in the machine? Okay, so we knew that this 1,500 was a number of sheets of paper that were used. So P would be, in this scenario, P would equal 3,500, right? Because that's 5,000 minus 1,500. I'll just write it down. 5,000 minus 1,500 gives us the number of sheets of paper that remain at 20 minutes. So P remaining in the machine, M minutes after the machine started printing. So our M is still this 20 minutes. Okay. So at the 20-minute mark, we would have 3,500 sheets of paper remaining. And we're looking for which one of these equations gives us that. So whenever we're looking for an equation that models a set or a state of being, so to speak, that models a value or two values together like we have here, P and M, I just use substitution as my method. All right, so I'm literally going to plug in these values and see, well, which ones of the answer choices gets what I'm looking for. So if P is 3,500, is it true that 3,500 equals 5,000 minus, again, 20 times 20, because M is 20? Well, 20 times 20 is 400. 5,000 minus 400 does not equal 3,500, so choice A is gone. For choice B, if I replace M with 20, 75 times 20 is 1,500. 5,000 minus 1,500 does, in fact, equal 3,500. So B is a good answer. Now, I've learned to not stop there because there are times when, especially when you're using substitution or plug-in, you may get two possible correct answers. So I'm going to continue to go with this. So this time, M, if I replace M with 20, 20 divided by 20 is 1. 0.3 to the first power is still 0.3, and 5,000 times 0.3 is 1,500. Again, we wanted P to be 3,500, so that is not equal, and choice C is gone. Choice D, same thing. Replace M with 20. 20 divided by 20 is 1. 0.7 to the first power is still 0.7. 5,000 times 0.7 is, oh, look at that. It is equal to 3,500. So we end up with two decent answers. So let me erase all this and just remember that B and D were both good, right? But A and C were definitely out. So what do you do when you get two good answers on the math section? We just plug other numbers in. So what other numbers could we use? Well, don't forget, our rate is 1,500 for 20 minutes. And that's used, right? Which would mean that after, let's say, 40 minutes, the machine should have used 3,000 sheets of paper. Okay. But our p-value is not in regards to how many sheets of paper were used, it's in regards to how many sheets of paper remain. So if 3,000 were used, that means our p-value would equal 2,000. There's 2,000 remaining out of the total 5,000 that we started off with. But our M would still be 40 minutes. Okay. So now I'm going to try 2,040 to see if those also work for B and D. So in this case, that means M is 40. Again, P we want to be 2,000. So is it true? Is it true? All right, so 75 times 40 is 3,000. And 5,000 minus 3,000 is 2,000, so B still works. Let's try D. So now we have, this would be 40. 40 divided by 20 is 2. So we have to do 0.7 to the second power. So 0.7 to the second power is 0.49. So we'd have then 5,000 times 0.49. And what I get from that is 2,450, which is obviously not equal to the 2,000 that we know P should be equal to. So now D is gone. So now we have a very clear-cut winner. Choice B is the best answer here.